Okay, let's have a look at this. Right guys, so, are you with me? I'm recording. I'm being rude. Oh no. So, what we've got to look at first is this whole, be able to find the sum of an infinite geometric series. Now you know the word infinite means it goes on forever. So how can you add to something and add it all up if someone's just going to give you another one, and then another one, and then it's like, how much, how many sweets do you have in total if every day I give you another one? Well, you can never say, can you? However, what we're looking at is a specific type of sequence, a specific type of series. So what I want you to have a look at is this one, okay? Now, this one, you should have realised that the ratio is what? A half. And because we have a ratio, a common ratio that is positive and less than 1, okay, we get the situation where the sequence gets smaller and smaller and smaller. Right? In other terms, if I were to graph this, it would end up with a what? The graph would have or the function would have a what? A what? An asymptote, good. It would have an asymptote. So it would reach, now that's the thing to realise. So if I asked you to find the sum of the first 20 terms, so you would have done S20 equals what? So you've done 2 times a half to the power of 20 minus 1 all over a half minus 1. Right? So we've kind of done it the wrong way around in that maybe we should have done it the other way around because we then get a negative, but it's not a problem. So we've got S20 equals, well, what do we end up with? Pardon? 3.9999, okay, over, or is it just that's it? That's fine. That's the final answer. Okay? Alright. What is sum of 100?
4.
Okay. Alright. Does that mean it's exactly 4?
Yeah.
Because what would you predict the sum of 150 terms would be?
4.
But how can that be possible? If I'm adding and I'm getting the same answer. That's brilliant. Okay, so now we've got the situation. Is S of 100 4? It's approximately 4. We can give a squiggly one. And S of 150 is approximately 4. The sum to infinity is 4. How can I say exactly when sum to infinity means go on forever? TOK, come on. Something that goes on forever. Right? Now, this type of sequence is called, okay, a convergent sequence. Because what happens is, it gets closer and closer and closer and closer to another value. It doesn't actually get there. That's the whole point of an asymptote as well, isn't it? It will never actually be 4. Alright? But it will be so close that your calculator doesn't tell you the difference. Alright? Now, can you spot where in this formula for the sum, where the whole point that the difference from one term to the next gets so small that it's really no difference? Can you spot in there where I would see that that's not going to make any difference if I go any further? But check your understanding of numbers and stuff. If I wanted you to do the sum of 100 and then 101, what in the formula would change here? What would change?
The square, not the square. The
So the power of 20. So I just want to have a look. What, if I do a half to the power of 20, what is that the same as saying? That rules of indices. Well, it's a half times half, but it's also 1 to the power of 20 over 2 to the power of 20. 1 to the power of 20 is 1. Okay? 2 to the power of 20 is a big number. And if you make the denominator of a fraction really, really big, what does that actually do to the fraction? Makes it really, really, really small. So every time I add another value to the power, the fraction gets smaller and smaller and smaller. But it's going to get half the size, isn't it? So a half to the power of 1, a half to the power of 2. Well, half to the power of 2 is half as big as half to the power of 1, and so on, isn't it? So a half to the power of 21 is half as big as a half to the power of 20. Got that? Make sense? So, what is half of not very much? But not very much. Okay? If you've got, you know, who would it hurt more? Someone with 500 francs in their pocket to say, I'm going to take half your money, or someone with 2 francs in their pocket to say, I'm going to take half your money. Who would be the most bothered? The 500 franc guy, because he loses a lot. The one with 2 francs in his pocket doesn't really matter, because half of 2 being 1 make it even less important. If I've got 1 franc in my pocket and you take half of that, oh well, you know, doesn't matter. So as the number gets smaller and smaller and smaller, the difference between one term to the next is smaller and smaller. And then what do I do when I found the next term? I add it to what was there before. But if what I add on is so small, it makes very little difference indeed. Well, that's not going to make any difference. Well, I say that, but does it make a difference? It does make a difference, but a tiny, tiny difference. So this 2 to the power of 20, or a half to the power of 20, is so small that your calculator won't even bother telling you the answer. That's why. Did you put it in and get the answer 4 exactly from your calculator? Yeah? But it's not 4, it's 3.9999, like you saw here, for, I don't know, 100 decimal places. Where did your calculator stop? You know, 8, 9, 10 decimal places, then it just goes, that's 4, we'll have it. Okay? So that's the thing. So we've got a convergent sequence. As we go on to infinity, it's not that it stops and gives you an exact value, it just means that if I go too far, it's not going to make any difference whatsoever. Okay? Yeah?
Let's see if R was 1 1.
So that was my next question. Alright? So we've got a convergent sequence. Now, a convergent sequence only happens when R is less than 1, okay, greater than 0. Right, now I've got a question mark here. This greater than 0 bit. What happens if R is a negative fraction? Will it still work? So here's the question. There's one for you to have. Have a look at this now. What if this sequence that I gave you, right? So we all understand. Actually, let me just check first. If R is 3, why can't you find the sum to infinity when R is 3? I will check your answer. Because it's getting bigger and bigger and bigger. And R to the power 3 to the power of 100 is huge. 3 to the power of 101 is 3 times as big as huge. Therefore, you add on, it keeps getting bigger and bigger and bigger. There is no sum to infinity when it just gets bigger and bigger, because the whole point is that the value gets smaller and smaller and it makes no difference. So my question therefore is, if R for this sequence to what? Well, let's say R is minus a half. What would the sequence be? 2. If you have to do 2 times minus a half on your calculator, I want you to reconsider the position in this class. I'm sort of being sarcastic. What is 2 times minus a half? Minus 1. The next number will be a half. The next number will be negative 0.25. Right. I want you to consider. Can I do, is this a convergent sequence? And can I find the sum to infinity of it? Let's think about it, because some of you don't like thinking and you wait for someone to tell you the answer. Let's think of it in a visual way. I'm just going to draw this for you. Right? I'm going to draw. Okay. Reason why I've done that. So, if I plot values, so I've got 1, 2, 3, 4, and so on, yeah? On this axis. This is my N axis. This is my SN axis here, right? Right, so, the sum of the first terms is what? The sum of S1, what is it? 2. Okay, so I can put a mark. S2?
Minus.
No, not for this one, the original one, sorry, maybe my fault. The original one, so I've got 2, 1, 0.5, 0.25 and so on. So it'll be 3, and then it will be and so on until we end up with up to 4. That's what we ended up with, wasn't it? So I would have, this is called a what again? An asymptote. So that would be, that value would be my sum to infinity as n goes to infinity. So that would be it. What happens though if I use this other one? So it would be, the first point's the same. What's the next point? So then it's 1.5, then it's... Would we not end up doing... So would that change the asymptote? So it'd be either side, maybe something like that. Yeah. So it won't be the same value, will it? As but will it? Is it a convergent sequence? Is the first. So it's still a convergent sequence. So I can have a negative value of r. That's what we were talking about. For this one, did you work out what sum to infinity is? Does that make sense? 1.3? Yeah. Okay. So you can see how we've got to potentially adjust this up here, then, haven't we? So we could say r is actually less than 1, but greater than what? Minus 1, but we have to add one thing into this. What do I have to add to that? Yeah, r cannot be 0. Okay, so if you see that notation there, you know why, right? Because we can have these negative, they still give a convergent sequence. Alright?